All right, we're working with ellipses and hyperbolas, and these are more conic sections. So again, in that TI, if you hit the apps and go down to conics, you will see all of them, parabolas, circles, and now you're also going to notice ellipses and hyperbolas, which are very similar looking in the equation, but very different in the graph. So do you know the relationship between the center, the foci, the intercepts of an ellipse, and the equation of an ellipse? So we're going to start with ellipses. An ellipse is a set of all points P in the plane such that the sum of the distance from P to two fixed points is a given constant. Well, that probably means nothing to us so far. But what we do know is that an ellipse is not a circle. It's more of an ovular type circle, so it looks like a football or an oval. And we're going to look first, you know what, let's go ahead and look at this right here. We're going to look at the ellipses. The ellipses that we're going to start working with have a center at 0, 0. So notice this is where the center is. The hardest part of an ellipse is what we call this foci. So this foci at negative C and positive C0, that is a point kind of in between, not right smack dab in between, but between the center and the vertices of each ellipse. Notice that we have x squared over a squared plus y squared over b squared is equal to 1. It's always going to equal 1. So notice we start these off at 0, 0, and we're going to go a this way, and b this way and this way. So notice that it changes because the b, the number whatever it is under the y, is going to go top and bottom along the y-axis, where the a under the x is going to go over the x-axis. And notice when it changes, notice that the a now changes to be bigger and it goes underneath the y. So notice that it has changed right here to be under the y, because they call this the major axis. In this case, the major axis is now going to be under the y. So we know, we don't really have to know a and b because we know the larger number will be under the y. In this case, the b's are on the x-axis, and the center still remains at 0, 0. So we're just working with ellipses with center at 0, 0. And notice that all ellipses have a plus, and they're all equal to 1. So let's start by graphing, because graphing is always fun. These are super cool. We know that all ellipses that we're working with right now are going to have a center at 0, 0. Okay, now eventually that will change. We'll have a number thrown in right there, but we don't have that right now, so we don't have to worry. The next thing we're going to look at is this 25. So on the x-axis, I do notice that I have to take the square root of 25, which is 5. And I'm going to put a dot to the right. And I'm going to put a dot to the left. And I will notice that the 9, which is smaller than 25, well, that's a perfect square. So I know on the y, I'm going to go 3 up and 3 down. So when I graph my ellipse, graphing paper always makes your graphs look better. And drawing on this iPad makes my graphs not look so good. But that wasn't too bad. Notice that my ellipse has a center of 0, 0. We're going to go 5 to the right and left because we have to take the square root. Remember, this is the a squared right there. And this would be the b squared. And in this case, I don't really need to worry about a and b because I know that the a squared will be the bigger number. So it just told us to graph that one. Good job. All right, on the next one, the first thing I have to notice is they're asking us for a bunch of different stuff. So it's telling us to give the x and y intercepts, which we can do. I'm going to graph it so we can see it. And we do have to find that foci. So we do need a formula for the foci, which I will get to. The first thing I notice is that this ellipse is not equal to 1. So in order to make it equal to 1, I always divide. So I'm going to take 144 and divide it here and here and here. What I do to one side, I have to do the other. Well, when I do that, I get a new equation. These cancel out to be 16, and 144 divided by 4 cancels out to be 36, and this becomes 1. So it looks like I end up with x squared over 16 plus y squared over 36 is equal to 1. So I'm going to put that right there. And let's answer all these questions. The first thing I like to do is I'm going to graph because I want to see. Now I do notice that the major axis is on the y this time because the 36 is greater than 16. So on the y, I have to go 6 points to the top. Oh, I just made it. I have to extend that. 6 units to the bottom because I needed the square root of 36. And under the x, I need that square root of 16, which is 4. So I'm going to go 4 to the right and 4 to the left. And when I draw this ellipse, I'm going to draw it in purple. It looks just like this. So the first question told us to name the x and y intercepts. So notice the x-intercepts are at plus or minus 4 and 0. This is our center, so notice that is an x-intercept at 4 and negative 4. My y-intercepts are going to be at 6 and negative 6, so I need to put 0 and plus or minus 6. Well, let's see what else they asked me. Oh, we have to find that foci. So we do need a foci formula, so if you write this down, that would be just wonderful. The foci, we are going to use a squared minus b squared is equal to c squared. Well, remember a squared is always the largest number, so my a squared in this case is 36 minus the b squared is 16, and that's going to give me c squared. 36 minus 16 is 20, where c, when I take the square root of each side, is 2 root 5. Now, that is just saying on the major axis, I'm going 2 times the square root of 5, which is about 4.5. So I'm going to 1, 2, 3, 4.5. It's about there and about there. So I actually have to call that what it is, that point. So notice when this center starts changing, I have to call the foci at the point it is at. Well, since it's on the y-axis and it's at 0, I'm going to say 0 plus or minus 2 root 5. Now, if that was a 1, we would have to put 1 plus or minus 2 root 5. But because it was a 0, we can show it right there at 0. So we do need to know the foci formula, which is right here. Notice that all ellipses are a squared minus b squared equals c squared for the foci. I did not give you that before, so you do need that for your notes. All right, we're going to do one more. The first one is not even equal to anything. So I have x squared plus 4y squared. I need to bring that 16 over. And now to make it equal to 1, I have to divide everything through by 16. So what I'm actually working with is x squared over 16 plus y squared over 4 is equal to 1. And all it does is ask us to graph it. So I know the center is going to be at 0, 0. I'm going to graph the square root of 16, 4 to the right and 4 to the left, because that goes right off the center. And the square root of 4 is 2 up, 2 down. So my ellipse, notice the major axis, is on the x-axis. So remember, for the foci, I have to name them from the point 0, 0, because that's the center. I have to take the a squared, which was 16, minus the b squared, which was 4, and that gives me c squared. 16 minus 4 is 12, and when I take the square root of each side, c is equal to plus or minus 2 root 3. 4 and 3 can break down that 12. That's not the answer. Remember, I have to answer the foci from the center. So since that center was at 0, 0, and the foci are going to be about here. Oh, let me do a brighter color. Oh, let's do yellow. They're going to be about here and here, because root 12 is closer to, well, it's right in between 3 and 4. So I'm going to write it using this plus or minus 2 root 3, but that's going to be on the x point this time, because notice the foci are on the x-axis. Great job.